Please title these notes Geometric Applications to Notes, More Area, specifically it's evaluating. By the end of this lesson, you should be able to evaluate expressions for area both with and without the calculator. You should also be able to find bounds if you aren't given them. So let's go straight for an example. We are going to find the area bounded by f of x, g of x equals 1, and x equals 2. Oops, x equals 2. There we go. And let's say that we're given those. So here is f of x. It is the square root of x plus 2. And let's say that this is g of x. Put it down here. That's x minus 2. And x equals 1 is here, x equals 2 is there. So, just like we were doing in the previous lesson, we want to go and we want to mark that area. We want to go and sketch our representative triangle, rectangle, and the width is dx. So we know that we're going to start our rectangles at x equals 1. We're going to end at x equals 2. We have a width of dx. F of x is this equation here on top, so we're doing f of x minus g of x. And we can substitute in for f of x. And we have an expression just like we did in the previous lesson. In today's lesson, we want to turn this into a single number, evaluate it. Now, we can just break this up into different integrals and do it by hand, like we've learned how to do in the past, but that wastes a lot of time. So what the number one thing to know about these area problems are, look and see if you have your calculator available. If you have your calculator available, use it. The dragon says, use your calculator. Rawr. So, remember the notation that we use is, here I'll write it over here, finite integral. Then we're going to have our expression, our variable, lower bound, upper bound. Remember, this is reversed from how we plug it in when we're doing it by hand. So, with this right here, remember we're going to math, and then down here to finite integral. That's 9. Our expression is the square root of x plus 2, close parentheses, minus in parentheses, x minus 2, comma, our variable is x, our lower bound is 1, and our upper bound is 2, right like that. Always round to 3 digits after the decimal. This is extremely important. It is a convention on the AP test. If you do not do that, you will get the problem wrong, and I will cry, and the dragon will eat you. It is really common to have questions where you're given neither the graphs nor the starting and ending points, the bounds. If you have your calculator available, these are still quite easy problems. So let's do another example. Find the area bounded by f of x equals x squared minus 3 and g of x equals 1. If you have your calculator available, all you have to do, go to y, enter in x squared minus 3, and then y equals 1. Graph, oops. There we have our graph. You got to remember which one's f of x, which one's g of x. The one that was drawn first, also the squared one, is the one that was first in the equations that we entered. Make sure you label these though, because it's really a pity if you just get the wrong one and that's the only thing that messes it up. And now when we're doing this, notice that we were not given anywhere in the problem what these x values are. So right here, we need to know our starting x, and right here we need to know our ending x. And we can find that just by using the intersection command. So that's second calculate, going down to intersect here. Just like before, we're going to go over where we're somewhere near the curve. Hit enter. It's going to switch us over onto the second curve. We hit enter. Then when we hit enter a third time, it'll give us the x and the y coordinate for that intersection. So in this one, x equals 2. On the other one, we do that again. Second calc, intersect, that's number 5. Go over here. It says x is negative 2. From here, it's exactly like we've done in the past. So we're going to set up, here's our rectangle, it's dx, we're doing the integral from negative 2 to 2. G of x is on top up here, so g of x is 1. Then we're going to subtract f of x, which is x squared minus 3. And our width is right here, it's dx. So again, if we have the calculator available, all we have to do is put in finite integral 1 minus, make sure it's in parentheses, x squared minus 3, comma x, comma negative 2, comma 2. Math, that's math 9. 1 minus parentheses x squared minus 3, comma x, comma negative 2, comma 2. And there's our answer. The little bar over it means repeating. That gives it an exact answer. I don't have to write out all the decimals because they're already contained in that bar. Sometimes, though, we're not allowed to use the calculator. There is that calculator-free portion of the test. So when we have no calculator, there are a couple of things that are really important to know. One is know your parent functions. You should be able to sketch a graph more or less by hand. So you should know that f of x equals x is a line that looks like this. F of x equals x squared looks like that. F of x equals x cubed looks like that. F of x equals the absolute value of x. That's that V shape. Other common ones, f of x equals cosine of x. That's got the peak right about on the axis. F of x equals sine x. That's going through the origin. F of x equals 1 over x. And that looks like that. F of x equals some number a. That's a horizontal line going through y equals a. And actually, that's not it. It's not an f of x at all. It's just an x equals b. This is also known as y equals a. Vertical line going like that. You should also be comfortable with your transformations. And if you're not comfortable with any of this, that means that you should sit down and memorize it. Pretty much just memorization. But if you have a function f of x and you add a to it, that moves it a units up. If you have the a inside, that moves a units left. That's the opposite of what you would expect. You'd expect a positive to move positive in the x direction. It's actually moving opposite of that. And the other important one, negative f of x, flip something over. There are some other ones that do stuff with stretching and shrinking it, but to get the basic shape down, that's all we really need to worry about. So let's look at one that we're going to do without a calculator. Find the area bounded by g of x equals negative x, h of x equals negative x squared minus 2, x equals negative 1, and x equals 1. So we have to sketch these by hand. So we'll start off with our axes. And let's start off with g of x equals negative x. We know that normally x looks like this. A negative x flips that over, so we're going to have a function going down like this. And then negative x squared would look like this. It's negative, so it's been flipped over. Minus 2 moves it down 2. So we're going to have something that looks a little bit like that. We see that our bounds are x equals negative 1 to x equals 1. We can see g of x is on top, so we're going to have the integral from negative 1 to 1. G of x is negative x. And then we're going to subtract negative x squared minus 2, because that one's on the bottom. And the width of one of our representative rectangles, that's dx. So, if we don't have the calculator with us, so I'm going to mark this no calculator. Then after we've sketched it, we just have to work this out by hand. So we're doing integral from negative 1 to 1, negative x plus x squared plus 2. Negative x squared over 2, I'm taking the antiderivative, plus x to the third over 3 plus 2x. All this from negative 1 to 1. So negative 1 squared over 2 plus 1 cubed over 3 plus 2 times 1. And then we're going to subtract negative 1 squared. Remember, that's in parentheses. Plus negative 1 cubed over 3 plus 2 times negative 1. Okay, that gives us negative 1/2 plus 1/3 plus 2 minus, so negative times negative is a positive times a negative is 1/2 plus negative 1/3 minus 2, and then we distribute this negative, these two subtract to be 0. So we have 2/3 plus 2, which is, plus 4 times 3/3, so that's 2/3 plus 12/3, or 14/3. You can also find the bounds by hand if you need to. Let's say this is also no calculator. Got the area bounded by f of x equals 2 minus x squared and g of x equals x. So when we're drawing this, we know that g of x equals x is just a line like that. This is negative x squared plus 2, same thing. So negative x squared is upside down, plus 2. It's going to be coming up something like this. Now, as soon as we figure out what these numbers are, so whatever x equals over here and whatever x equals over here, we can put them into our bounds. Here's our representative rectangle. We don't know what those bounds are yet, but we do know that we're going to have a dx. We do know that f of x is on top, so that's 2 minus x squared minus g of x, which is just plain old x. And what we do to find the bounds, the intersection points are the points where the f of x and g of x are equal for the same x. So all we have to do is set them equal to each other. So g of x is x, f of x is 2 minus x squared. If we have an x squared and an x in here, what we want to do is we want to get everything on one side and set it equal to 0. So I'm going to add x squared, subtract 2 to both sides. Because once it's equal to 0, I can factor it. And then use that in order to figure out what these two x values have to be. So this is clearly the negative one, and this is the positive one. So that gives me my bounds here from -2 to 1. This is almost identical to the one that we just did, so rather than taking the time to do this one all out by hand, I'm just going to check and see what the answer is. So math 9, 2 minus x squared minus x, comma, -2, comma, 1. That's going to be 4.5. I leave it as an exercise to you to work that one out. This concludes Geometric Applications 2 notes.